This presentation is about the difference between the terms concentrated and dilute and weak and strong. The first two terms are referring to the amount of water, as they are in normal English. A dilute solution is one that has more water. Weak and strong is referring to how many of the molecules break up into ions. If an acid is a strong acid, it breaks up completely into ions. There are no molecules. So if you have a 0.1 molar solution of hydrochloric acid, an example of a strong acid, you'll get 0.1 mole per litre of the hydrogen ions. Whereas with a weak acid, acetic acid would be an example, most of the molecules stay together and only a few of them break up into ions, releasing the hydrogen ions. There needs to be some hydrogen ions released for a substance to act as an acid. So in fact, we have 4 possible combinations, because we can have dilute and concentrated solutions, and within those subsets we can be representing weak and strong acids. In the next slide, we're going to make a model of that, and referring to our P, the rice is representing the water. When we have a white and a red bead together, we're representing a molecule of an acid, and we're breaking them up. The white one's representing the hydrogen ion. The red one is representing the anion part of the acid. For example, for hydrochloric acid, that A- would be the chloride ion. The 2 petri dishes on the left would be representing dilute solutions because they have lots of rice representing water, whereas the 2 petri dishes on the right would be representing concentrated solutions, one without much water. The 2 petri dishes on the top are representing strong acids because there are no molecules present. All of them have broken up into ions, so they'd be representing something like hydrochloric acid. The bottom 2 are representing weak acids because most of the molecules are still intact, and in each of the petri dishes we just have a few that have broken up into ions. So that would be representing a weak acid. So just to summarise, this beaker is representing a strong acid that is dilute, lots of water present. This beaker is representing a strong acid that is concentrated, not much water present. And the bottom 2 are weak acids, with most of them as molecules, this one being diluted and this one being concentrated. Now, it is possible using the indicator methyl violet to work out, in the case of our example of acetic acid being a weak acid, how much of it actually stays together as molecules. Here in the next slide, we have 1 molar acetic acid and 1 molar hydrochloric acid, and you can see when methyl violet was added to both, they're different colours because each of them have a different number of hydrogen ions. We know this one has a lot more. We're keen on knowing how many hydrogen ions we are making with the weak acid, acetic acid. So what's been done is that solution has been subjected to a 1 in 10 dilution to make a 0.1 molar solution. And when the methyl violet was added to that, we can see that it is a light blue, still not the purple. Doing a successive dilution on that, so taking a 1 in 10 dilution of this solution, we created the 0.01 molar solution of hydrochloric acid, and now we can see we have a match, that we have the same number of hydrogen ions in this 0.01 mole solution of hydrochloric acid as in the 1 molar solution of the acetic acid. That tells us that we have, for every 100 molecules of acetic acid, weak acid, we only have 1 of them breaking up. Thank you for watching this presentation.